I saw this explained like I'm 5 about what would happen if you shone a laser on the moon and swung it around such that the dot moved on the surface of the moon faster than light. To get a few things out of the way, yes, the dot will appear to move back and forth faster than light, but no information would actually be moving faster than light. This is because the dot is not a thing, and any changes to the dot have to move at the speed of light from Earth to the moon, then back again for you to perceive such change. That being said, depending on where you stand, you might see some freaky business. I created this little horribly simplified simulation of what would happen. I have a gun, in yellow, set up to swing around and shoot a laser at the moon up here. The slider over here controls how fast the gun swings from left to right. I have also set up 3 detectors, one on the moon's surface, one on Earth, and another I can move around. For now, I have set it up close to one end of where the dot can move to. These 3 displays will show us where each of the detectors perceives the dot to be at a given point in time. The laser will be shot out of the swinging gun and make its way to the moon. A sphere of photons will be emitted on the moon, which will hit the detectors. Since we only care about the photons that hit each detector, we will not show the entire sphere of photons, and instead only consider those photons that actually will end up hitting the detectors. This is what a short burst of the laser looks like. Notice how once it hits the moon, 2 beams seem to be emitted from the moon that target each of the detectors. Also notice that the detectors detect the beam hitting the moon at different times, with the moon detector first, and the Earth detector last. This is because the light has to travel to get back to the movable and Earth detectors, while the moon detector immediately detects when a photon reaches its surface. Let's turn on the laser and let it swing for a bit. You can see how the dots on each of the displays are slightly offset from the aforementioned delays due to light having to travel longer distances. Oops, I just realized I messed up, guys. The displays are actually mirrored for some reason. I will overlay a mirrored version of the display from here on out. Let's speed things up a bit such that the dot is moving at the speed of light. While the moon and Earth detectors don't see anything weird, just a dot moving back and forth at the speed of light, the movable detector does see something weird. As the dot moves across the surface of the moon towards the movable detector, the dot catches up to the photons already moving towards said detector, so they all arrive at the exact same time, giving the appearance of the dot moving to the right at near instantaneous speed. On the other hand, the photons that show the dot moving away from this detector cannot catch up to the dot until the dot is already close to the detector, which makes it appear that the dot moves to the left at half the speed of light. If we increase the swing speed to the max, we kind of can't really tell what is happening, but at a more modest speed of 1.5 times the speed of light we see some interesting effects. Now, the movable detector never sees the dot moving towards it, only away, and the dot seems to teleport around on the moon's surface. Anyway, goodbye.